Now here we have below code from Wikipedia that does the same thing. And I'm not going to go through the logic here, but what you can see is it's quite a bit more idiomatic Python. It's actually quite a bit nicer than the code that I wrote. So if you like that better, then use this as a model instead of the code that I wrote. The code that I wrote is pretty kind of dumb and obvious. So we have equivalently a LUN valid checksum using the Wikipedia algorithm, which just does the obvious thing. And now what I have here is a random tester, which generates a random credit card number with a certain prefix and 15 digits, and then ensures that it's valid. The validity checking function for credit card numbers simply makes sure that it has the right length, that it has the right prefix, and that the checksum comes out to be 0. That is to say, the isLunValid function returns true. So that's all there is to it. And what I want to do finally is take a look at one other issue. So I'm going to comment out my code here and comment in some different code. And so what we're doing here is generating completely random 15-digit numbers. So what I'm doing is generating a random integer between 0 and the smallest 16-digit number. So the largest number that could be generated here is the largest 15-digit number. And then we're going to zero fill, convert that to a string, and do a zero fill operation, which adds leading zeros. So now we have a completely random number that's 15 digits long. And if that checks out to be a valid credit card number, we're going to increment our validity checker. And then finally, after doing this 100,000 times, we're going to print the number of valid credit card numbers that we got. So let's run this and see what happens. Okay, we got no valid credit card numbers out of 100,000. So the problem is the prefix was too long. With a 6-digit prefix, the chance is 1 in a million that will generate just this prefix, and then it goes down to about 1 in 10 million that will meet the prefix and the checksum requirement. So if we start off with a much smaller prefix, like just 37, this is basically anything in the American Express system, I think. Now let's see what happens. So we're going to generate 100,000 credit card numbers, and 104 of them came out to be valid. So even with just a 2-digit prefix, it's pretty unlikely that we generate valid credit card numbers. And so what that means is, if we're generating lots of invalid credit card numbers, of course, we're stressing only the very small bit of our transaction processing logic that checks for valid credit card numbers. And we're not stressing the rest of it. So what I hope I accomplished here is, first of all, motivated the fact that this generation of valid data is a real one. And second of all, giving you a little bit of a feel for what code looks like that we usually have to write to generate valid inputs. And so if we go back to our web browser example, you can see that we would be doing a similar exercise, but it'd just be quite a bit more sophisticated to generate, for example, valid HTML or valid HTML with scripts and other things that it would take to actually do meaningful fuzzing of the web browser, as shown by the blue line here. And so now to do this, instead of spending half an hour or however long you spent on that API quiz, now maybe you're going to be spending many weeks. But on the other hand, what we're going to get out of this, if we do it right, is a lot of high-value bugs, including security bugs, in our web browser. And it's strongly possible, though of course not guaranteed, that the value we get out of those bugs that we find in the web browser, that our effort will have been worth it.